Hello YouTube fam. Welcome back to our channel. In this channel, we will be discussing various topics in the exciting world of AI, machine learning, and computer vision. Our content is crafted by our awesome human team, but here's the magic. It's finely tuned and optimized by our AI wizards, bringing you top-notch information. And guess what? The presentation is delivered to you by our AI hosts and voiced by our incredible AI avatars. Let's get started. In today's video, we are going to look at finding similar sentences using vector databases. We will use LangChain to demonstrate the similarity search. LangChain is a framework which makes working with LLM easier. It provides different modules to integrate with documents, vector stores, embedding models. We will look at the different vector stores like ChromaDB, PineCone, and Weaviate. Just a side note, in earlier videos, we have also looked at the Sentence Transformer util module and Facebook AI Similarity Search Library. Please refer to those videos as well. Also, you can refer our earlier video about RAG to understand the power of vector databases. Vector databases are typically employed for performing semantically relevant similarity searches. Consider a scenario where there's an internal knowledge base. In the event of a new query, the objective is to search the knowledge base and retrieve only the pertinent chunks of data. As a first step, we would perform embedding on the data in our knowledge base and store it in a vector database. When we see a user query, we would do embedding on the query and search the vector store for similar relevant content. For constructing the knowledge base, we'll generate a file named sentences.doc.txt. Keeping our discussion straightforward, we'll include a few sentences in this document. Examples of such sentences include "the baby cried for milk" and "the car drove away." We can use the LangChain text loader function to load the knowledge base document into memory. The embedding models work well with smaller chunked data, as it helps to retain relevant, meaningful information. Having the whole documents or very large chunks will make it include non-semantically relevant data. We will use the character text splitter and split the documents into chunks. We can see that there are 5 chunks for this example. We can then embed them using the sentence transformer embeddings. For now, we will just define the embedder. We will use pre-trained model all-mini LM L6 v2 as it is very fast. Just for testing, we will embed the query hello. We can see that the dimension of embeddings produced by all-mini LM L6 v2 is 384. First, we install the in-memory version of ChromaDB. Then import the Chroma class from the LangChain community.vectorstores module. In ChromaDB, we store embeddings, documents, and any additional metadata in collections. This method, chroma.fromDocuments, is used to create a Chroma collection and add documents and embeddings. We want to find most relevant document corresponding to the user query, "the truck was fast." We perform a similarity search using the Chroma database. As we can see from the output, the most relevant sentence from the knowledge base is "the car drove away," which seems correct. We can also look at some other useful ChromaDB commands. We can do things like collection.count, collection.peak, and so on. We can go to PineCone website and sign up for free. We have to create project and then create API keys. We can then pip install PineCone client. Once we grab the PineCone API key, we can create a PineCone index. Starter plan indexes are hosted in the GCP starter environment. We use the pinecone.createIndex command. The dimension is 384 as the dimension of embeddings produced by all-mini LM L6 v2 is 384. We can then connect to index and view index stats. Initially, we will see a total vector count equal to 0. With the index created, we can now add documents and embeddings. The method pinecone.fromDocuments is used to add documents and embeddings to PineCone index. It might take a minute or two for PineCone index to be ready. Check if their total vector count equals 5 before running search. We want to find most relevant document corresponding to the user query, "the truck was fast." We perform a similarity search using the PineCone index. As we can see from the output, the most relevant sentence from the knowledge base is "the car drove away," which seems correct. We can go to the Weaviate Cloud Console and sign up for free. We have to create a cluster in the free sandbox. It takes a couple of minutes for the cluster to be ready. Once the cluster is ready, we have to get the cluster URL and API key. Now that we have the cluster URL and Weaviate API key, we can create a Weaviate collection or class and add documents and embeddings to it. The method weaviate.fromDocuments is used to add documents and embeddings to the Weaviate collection. We then perform a similarity search. As we can see from the output, the most relevant sentence from the knowledge base is "the car drove away," which seems correct. We can also look at alternate ways than using LangChain. We can use the Weaviate.client. We can look at the class objects using client.dataObject.get function. It shows each of the 5 IDs, and under properties, we can see each text. We can also search for similar vector using client.query function. And there you have it. To summarize, we looked at how to find similar sentences using vector databases. We used LangChain and interacted with different vector stores like ChromaDB, PineCone, and Weaviate. We looked at sample code to bring all this into action. It's been an exploration filled with insights and algorithms. Thanks for watching. Stay tuned for more exciting adventures in the world of AI and machine learning and algorithms. If you found this video helpful, don't forget to hit that like button, subscribe for more tech talks, and ring that notification bell to stay updated on our future explorations. Until next time, happy coding and keep the curiosity alive. Thanks for watching.